IP convergence is not a new thing. Since the early 2000s, we've seen telephony, security cameras, building management systems, control and audio all moving across to IP platforms. And HDBaseT has done a great job of distributing high quality video throughout this time. The problem is, HDBaseT is not Ethernet. In this course, Bob Lockwood from Siemon explains how SDVoE is providing matrix switch performance across existing 10 gig Ethernet installations.
Hello everyone, welcome to SDVoE 2020. I'm Bob Lockwood with the Siemon company, and this segment we're talking about copper AV connections more than just continuity. So really quick, a little bit about the Siemon company. So we're a US manufacturer of telecom connectivity solutions since 1903. We're best-in-class IT infrastructure systems for the last 30 years. Well, basically since Ethernet has been a solution. And we're a leader in IT standards development. We actually represent 6 standard bodies related to structured cabling and Ethernet systems. And we're one of the latest members of SDVoE. So AV has been transitioning to twisted pair copper cabling and fiber for more than 20 years. And it started with Balin's, and now, last 10 years it's been HDBaseT. And Balin's has done a good job for what it was. It saw its time, and HDBaseT has been functioning great in this market. But there's one major issue, is that even though HDBaseT runs over twisted pair and fiber, it's not Ethernet. And since it's not Ethernet, it's not performing very well over a cabling structure that was intended for Ethernet networking. So there's a lot of inherent issues because of that. So now we have AVIP, and now AVIP is Ethernet, and it takes full advantages of all the networking you're able to do with the structured cabling system in the full distances that you can get out of Ethernet. So IP convergence is not new, right? So IP began converging onto phone systems back in 2005, voice over IP. And of course now we have security systems that are over IP. We have HVAC, lighting systems, PoE. So a lot of technologies have already converged, and AV is just one of the latest ones that's converged over. So there's some obvious benefits to why convergence is happening on Ethernet. So there's certainly lower equipment cost. So a lot of the infrastructure already exists with the network switches and the cabling infrastructure that's already in the walls. So really there's a lower OPEX and a higher ROI for cabling infrastructure. It's the ease of installation. It's non-proprietary cabling systems. So again, it's whether it's Cat5e, Cat6, Cat6a, whatever infrastructure the AV system can run over, it can be utilized. And then obviously there's networking of the AV equipment and remote control from centralized locations. So without a doubt, I think what we see as far as topology concern, HDBaseT and AVIP is most commonly used as a direct connect, which is point-to-point. So really it's from either the matrix switch to the display, or from the Ethernet switch to the display. Now, there's really nothing wrong with this for a lot of applications, but it does have potential issues. So if it's a permanent install, where you're not moving any of the cables on either end, it's fine. So in other words, if you're not unplugging and plugging at the display end or on the head end, it works fine in most applications. But there could be problems if the installer or the user is going into the system and they're unplugging and plugging on each end. Well, horizontal cable that runs between the two devices is solid conductors. And you know with solid conductors, like take a wire and you bend a wire several times, you're going to start stressing that wire, and eventually that wire is going to crack. Well, that's the same thing that's going to happen with horizontal cable. It's a solid conductor. So both applications, HDBaseT and AV over IP, run just perfect over this. So now we introduce patch cords and we introduce a patch panel. Now the benefit to patch cords and patch panel coming from the matrix switch or the Ethernet switch, the benefit is now you're starting to protect that horizontal cable, that solid conductor that you have running between the devices with a patch cord. Patch cords are made out of stranded conductors. And patch cords can be flexed. That's why they use stranded conductors. They can be flexed hundreds of times. And the benefit of also patch cords, where if over time they do see damage, you can easily replace the patch cord, but you don't have to replace that 90 meters of horizontal cable that you have installed, whether it's running through the walls over the ceiling. I've talked to a lot of AV integrators where if they do have issues in the field, they said, yeah, we just go back out and we re-terminate the end. Well, you can re-terminate the end, but still, there's going to be a period of time where you're going to degrade that level of cable and it's going to degrade your service over time. Oh, just run one quick point on this as well is when you start adding patch cords and a patch panel, well, now HDBaseT starts to get a little sketchy as far as its performance. Now we know 4K 60 666 on HDBaseT can run over 90 meters of point-to-point cable, but it starts getting really questionable as far as if it can run over patch cords in a patch panel, because every time you introduce connectivity, you're introducing loss into the system. So it's anyone's guess, based on any one OEM's system. It's anybody's guess, will it run over 90 meters when you're introducing patch cords and patch panels? Where on the AV over IP system, there's not an issue. It's a standards compliant system. Ethernet runs all day long on this configuration when you're introducing patch cords and patch panels over full 90 meters of horizontal cable with another 10 meters of patch cords introduced into that. So now this is typical on a structured cabling approach. It's called the two connector channel. So this is the case where you're introducing now two patch cords, a patch cord on each end. So again, this is probably the best system where it's a semi-permanent install. On each end, you have the ability to change the display. Maybe today it's a video wall. Tomorrow it could be a kiosk or a workstation. So the benefit here is that you're able to unplug and plug new devices in, and you have the patching opportunity on the patch panel end. So without a doubt, HDBaseT cannot support this kind of configuration without derating it to 4K 30 or cutting back the length significantly down to 30 meters or 40 meters. But again, it's anybody's guess how it's going to work out. There's no standards defined. It's kind of it's a trial and error basically of what it is. I've talked to installers that they show up on the job with Category 6A and Category 6 cable. So in this configuration, they'll try to run the Cat 6A cable, and if they don't get video, they'll put in the Category 6A and give that a try. So I think it's kind of hilarious how some of these approaches are, because there's other ways around just plugging in the devices to see if you're going to get video or not. There's a whole testing procedure that can be gone through, and it takes the guesswork out of the whole equation. So finally, in this topology, we're introducing the backbone. So in the backbone, so we can get additional lengths. Now you're going from switch to switch. And in a backbone environment, if you're using copper cabling, you can get an additional 100 meters of length out of the copper cabling. Or if you're using fiber, you can, depending on the transceiver that's coming out of the switch, you can get an additional 300, 500, or 1,000 yards. And heck, if you wanted to go crazy, you can go to kilometers, right? So that's the huge benefit of flexibility, introducing a backbone. So in this example, you're looking at 200 meters of end to end using a copper infrastructure, or it could be 1,300 meters or 1,100 meters using combination of fiber and copper. So what are the advantages of AV over IP? So this is kind of a summary of our other slides, but it's a much more cost-effective solution. It eliminates the specialized gear. It eliminates the matrix switch, which is the biggest cost. So we've seen SDVoE members talking about the cost of matrix switches compared to Ethernet switches, and another huge benefit. So most organizations, most end users, and enterprise environments, they already have switches. They already have Ethernet switches as part of their LAN networking. So this can easily be incorporated into their LAN system without the need to purchase additional equipment. And it eliminates the redundant dedicated cabling. So right now, AV infrastructure is on an entirely separate cabling system than the network. So in a lot of cases, in a telecommunications room, you have an AV rack, you have an IT rack, and the AV guys are told to stay out of the IT rack. Totally different cabling system. So there's another huge cost-effective benefits to that. And so the functionality dramatically increases by using a standards-based structured cabling system. Again, you have your choices of topologies, whether it's point-to-point, whether it's a full two connector channel. You know that AV over IP is going to work on that. There's no guesswork. So if you're using HDBaseT, anybody's guess if that's going to work out. And then, of course, improve quality and reliability using AV over IP. So it's time tested. We know that Ethernet has been around for 30 years. Structured cabling has been around equally as long, and it's a time-proven methodology. So the disadvantages of AV over IP. So here's the difference between AV over IP and what SDVoE is trying to do. So AV over IP, most of the systems right now are proprietary systems. So there's a lot of large OEMs here. You can't mix and match, Crestron with Extron, with Adlona, or any of the other devices that are out there. You're stuck with a complete end-to-end solution if you pick one particular vendor. So it's designed for gigabit Ethernet, and that's what is being promoted. So a lot of the OEMs are saying, hey, it's gigabit Ethernet, it's category 5E, category 6, or whatever's in the walls, it's fine for that. So I think that's great for existing infrastructure, but what's happening, certainly throughout the market, is that many of the IT professionals are upgrading from category 5E. That's an outdated system. Most systems are good for 5 to 10 years. Well, category 5E has run its course, and now any new installations that are going in are upgraded with category 6A. A really important point here is that these OEMs, they talk about that, hey, AV over IP can run on any Ethernet switch that you have. Well, it's not the case. If you go through any of these systems, you'll realize that a lot of these OEMs, they specify or they have a list of switches that their systems are compatible with. So they have to have a certified switch. So you're kind of out of luck if you have a Cisco switch or an Arista switch as part of your network, and you buy one of these proprietary systems and you expect to run that over your current Ethernet switch, it may not be on that certified list, and you might not be able to use it. So you're back into spending, the extra dough to buy a gigabit Ethernet switch. But by the way, it's going to be outdated in several years, up to being upgraded to 10 gig. So SDVoE has many of the same benefits of an AV over IP system, except for its open architecture. You can mix and match and upgrade with other vendors' equipment. So I know Justin, talks about, if you buy Dell switches and servers, and then later on you want to upgrade to Arista because Arista or HP has a big sale. Well, right now they're going to tell you if you want to buy those, then you have to dump a lot of the other Dell servers because they wouldn't be compatible in the situation of the AV over IP. Well, it's not the case in SDVoE. Well, everything is compatible, so you're allowed to go, when you upgrade, you can go and upgrade to another SDVoE Alliance member's equipment. And it is interoperable with 10 gigabit Ethernet switches existing, anything Arista, Dell, Cisco. And it does require category 6A twist to pair. which offers the lowest latency, highest bandwidth, and it supports 4K 6444 over the full length of 100 meters of a horizontal cabling system. So why Cat 6A? So Cat 6A is backwards compatible for all 10 gig, 5 gig, 2.5 gig, and 1 gig solutions. It offers the highest insurance to support not only today's networks, but tomorrow's networks for intelligent buildings and new technology. So visiting some of the OEMs, I overheard kind of a sales pitch on why they propose Category 5E, Category 6 solutions, because they said a lot of the educational facilities, they won't upgrade from 5E to Category 6A. Well, I just happened to have dinner last night with one of the regional IT directors up out of San Jose, who oversees 5 districts of schools. And he was saying that was hogwash, that they're all upgrading to Category 6A. So as the Siemon company in this environment, we see this all the time. A lot of our customers are all upgrading to Category 6A, and in a lot of cases, Category 6A shielded because it has a lot of benefits. So when we're talking about Category 6A shielded, we're over on the bottom right-hand side is a diagram. So when you bundle all of these cables together, whether it's Category 5E, Category 6, Category 6A, there's an electrical parameters that happen in that cabling. It's called alien crosstalk, and basically it's when the signals start bleeding over onto the other cables. Well, when you use the shielded cable separates those. It doesn't allow that crosstalk to bleed over onto the other cables, and that's really important into AV applications, especially on long run applications, and you have bundles of 24 cables coming back into a rack system. That's where alien crosstalk is going to be an issue with those high bandwidth applications. So, we hear quite often that Cat 6A is really hard, right? It's large, hard to work with. It's really expensive. Connectors are difficult to terminate and time-consuming. Testers are expensive, which testers are pretty expensive to properly test out any systems, whether it's Category 5E to Category 6A, and special tools are required. Well, for a lot of people that are kind of not in the know in the last 5 years, there's been a lot of developments in technology in the cabling world. So first of all, Cat 6A shielded, we're down to 28,000. So basically, that's just a little over a quarter of an inch. And we do have samples here that you can take a look at. We have horizontal cable samples shielded. Next one here is patch cords. So patch cords are very thin now. Where when Category 6A first came out, the patch cords, well, they were difficult to work with. They were almost 3/8 of an inch, almost a half an inch in diameter. But now we're down 20% thinner. Again, we have samples over here that's plugged into all of the gear. You can check out all of the patch cords that are in there are Siemon Skinny Patch Category 6A solutions. And then finally, field terminated RJ45 plugs. We're doing hands-on demonstrations right after this, and a lot of these the plugs. Well, most of the plugs can be terminated in about a minute or under a minute. Well, we actually have installers that are out in the field that can terminate these plugs in about 30 seconds. We have these challenges that go on, and we have these challenges that are out there on YouTube that you can go and Google Siemon Z plug. And we have these challenges of the installers that are out there, and they're racing. They're trying to get the best time, and we're down to 25 seconds, 30 seconds for the termination. And using the same technology, we have an outlet that's based on the same termination method. These outlets, Category 6A outlets, can be terminated in under a minute. So I encourage everybody to stop by after this and take a look at the hands-on demo. Feel free to grab one and do some terminations yourself. We're set up for that, and we have boxes of samples to take with you for evaluation as well. So finally, this is where we're really kind of getting to. It's more than just continuity. So whether you're running a point-to-point or you're running a complete backbone and horizontal structured cabling system, it's more than just plugging in the devices and checking your display to see if you have screen, if you have video. It's more than just testing a continuity or wire mapping with a tester. Really, it comes down to there's 10 test performance parameters required on a standards-based test using a field network tester. What we're showing here is a Fluke tester. It takes about 15 seconds to test, but I can tell you these testers, they are expensive. They're about more than $10,000, maybe up to $15,000. But consider this. Consider if you do an install and you set everything up, everything's working fine on day one because you have screen, and then you leave the job site and you get a call back because the video is out. Well, there's a lot of things that aren't taken into consideration when you're putting in an install and you're just checking screen to see if you have video. Is maybe on day one you have video, but there's a lot of parameters that affect that over time. So heat, humidity, and temperature cycling is going to affect that signal. Bend radius, continuous flexing. So on day one, when you do the install, and if you test that out with a field tester, the field tester is going to go and it looks at additional margin. It's not going to tell you that it's, it'll tell you if it's a marginal signal. And if you have a marginal signal, that's when these other parameters can come back and bite you, because if you leave that, then that parameter can drop, over a period of time, and then you're back out in the job. You're sending a truck back out. So you got to consider the cost of sending the truck back out. You got to consider the user experience. So if your customer is in a board meeting and their video goes out, well, who are they going to be pissed at, right? So there's a factor in here that should be considered when you're looking at justifying a field tester. So I think that's it. So if we did Tony Veach did a speak over, talk about fiber, AV over fiber. And if anybody missed that, you can catch that on the SDVoE Academy. And it's called Going the Distance, AV over Fiber. And it talks about the whole fiber solutions that are offered in the marketplace. And it kind of dismisses the fiber phobia of fiber. Thank you.